Okay, so last week I lost internet connection at my house, so I've been coming over to my parents' house. I'll probably have to do that this week, but it should get fixed soon. I've got a few things coming in the mail. But what that means is I haven't been able to check my emails. I'm going to check them tonight, and I haven't been able to load our previous meetings from last week. So I'll try to get those up soon. In the meantime, you guys have an exam to do. Exam 1 is on WebAssign. Due Wednesday. You also have quiz 1 on Canvas. I'm going to wait till after Wednesday to make any new homework. If you need more time on either of these, let me know. The way I feel is I want you to get practice, and you've paid for WebAssign, so if you want to go back and work on old assignments, I can give you more tries, I can give you more time. The homework is just set up to give you 5 tries, but I can give you like, I think unlimited tries or 100 tries, and I can give you help. When it comes to quizzes, I do the grading, so I can determine how much credit you get. On a test problem, it marks it right or wrong. So if you're concerned about a test question, let me know. I can override that score depending on what happened. So like if you don't get part of the problem and it marks the whole problem wrong, you can message me. I can check it. All right, let's do notes. So I want to do one more example for section 2.7, and then we'll try 2.8. And that's just the goal for now, is to finish chapter 2. Any concerns, any comments or questions? No. Is the meeting? Yeah, we've started recording. And again, I'll try to get recordings up as soon as possible. Okay, I don't know if it'll happen today, but tomorrow it's my goal. It's just to sit and update everything. All right, 2.7, last example. Just a reminder, I showed you that position function. Is usually called S of t. And the velocity function is S prime of t, like the derivative of S with respect to t. Or let's see, the limit as h goes to 0. Let's see, S of t plus h. Limit h goes to 0 of S of t plus h. Take away S of t divided by h. Okay, I was being a little confusing with leaving the t in here instead of actually the specific value of t. So I'm going to focus on that today. So we're going to have a position function and a certain value of t. Okay, S of t is negative 16t plus 45. t squared. Make sure. And then add 40. Okay, find the velocity when t equals 1 second. Okay. So for velocity, s prime of t is equal to 1, so s prime of 1. Okay, s prime of 1 is, the limit as h goes to 0. S of 1 plus h, take away s of 1, divide by h. 1 plus h is the first input to that function. Okay, negative 16 times 1 plus h squared. Okay, cool. Add 45. Minus. Okay, put in 1 to the function. Negative 16 times 1 squared, add 45. That's the numerator. Divide everything by h. Oh, okay. We've got the limit as h goes to 0. Let's see. This would be 1 plus 2h plus h squared. Just this part. So multiply all of that by the negative 16. So negative 16 minus 32h. Minus 16h squared. Plus 45. Okay, unfortunately, this is the numerator. I ran out of space on the whiteboard. But it's supposed to be that part minus this part, which is negative 16 plus 45. Okay, this is right one more time. Okay, negative 16 minus 32h. Minus 16h squared, add 45, add 16, subtract 45h. All right. That's going to add up to 0. Positive and negative 45. Got a negative 16, positive 16. That also adds to 0. So what's left is the negative 32h minus 16h squared over h. When I do this step, we'll factor out an h. So the negative 32 minus 16h. Close, divide by h. Okay, h over h reduces to 1. Negative 32 minus 16h. Now let h go to 0, so that part's going to go away. This is going to be 0. get negative 32. Feet per second squared. Feet per second squared. All right, so that's the end of 2.7. And we start 2.8. Okay, let's go ahead and draw a title. So derivatives as a function. Definition. The derivative of a function f of x is a function called f prime of x. Okay, it's written like this. All right, so denoted. Okay, I don't know if you've seen this before, but f prime of x. F prime of x. And it's a formula we've seen before. So f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. Okay. The difference is x is a variable, so you'll just put note. All right, let's see. Also, just another note, and when the limit exists. Okay. Just to let you know that, like, I'm not going to write it down, but f prime of x is a function that describes slopes of tangent lines. We should write that down. It's important. So, also, f prime of x is a function that describes slopes of tangent lines. Okay. To Okay, so the first one we're going to work through is just, we're given a function, we'll find f prime of x. Then the next one, we're given a graph, and we'll draw f prime of x. All right, number one. Okay, let f of x be, it's 2x cubed minus 5x plus 10. And then first we're going to find f prime of x. This is going to take a lot of scratch work, and I think we need more space. We'll set it up, but then we're going to need to turn everything and have space to work on the whole problem. So f prime of x is going to be the limit as h goes to 0 of f of x plus h minus f of x divided by h. So x plus h goes through the function and then subtract just the function itself. Okay, let's do this. Okay, the limit as h goes to 0. X plus h cubed, 2 times x plus h cubed, minus 5 times x plus h plus 10. And subtract the function how it was. 2x cubed minus 5x plus 10. Everything is over h. Okay, this part, x plus h cubed, and then multiply everything by 2. I'm just going to write down what I got. So I got 2x cubed add 6x squared h add 6h squared x, and then add 2h cubed. Okay, that's just this part here. Minus 5x minus 5h plus 10. And the rest of it will be sitting below, but this is all the numerator right now. Minus 2x cubed plus 5x minus 10. And divide that by h. Okay. I can already see this positive 2x cubed and a negative 2x cubed. So let's get that. Here's a positive 10 and a negative 10. Also same for 5x, negative 5x. I think that's it. All right, so from the pieces left over, we're going to factor out an h in the numerator and get the limit as h goes to 0 of h times 6x squared plus 6hx. And then plus 2h squared minus 5. Okay, h over h, that reduces to 1, and this is left over. We'll write down that limit and then do the limit after. Okay, so hopefully I got all this stuff. Okay, so that's gone. 6x squared plus 6hx at 2h squared minus 5. All right, let h go to 0. So that will be a 0, and that's going to be a 0. And what's left is 6x squared minus 5. All right. And all of that work was to get f prime of x. So we have f prime of x is the function 6x squared minus 5. I like to highlight stuff. Okay, I put a little extra piece to this. Part B. Find the slope of the tangent line at x equals 1. Okay, so f prime of 1. Put 1 into the function we just found. 6 times 1 squared minus 5. All right, so I've got a list of notes on how to draw the graph, and then we'll try drawing one together. So, any questions on this example? Okay, gonna erase. Okay, so let's just do like bullet points. Okay, first one. We can estimate the value of the derivative at any value of x by drawing the tangent line. Okay, so we can estimate the value of the derivative f prime of x at any value of x drawing the tangent line. And estimating the slope. And estimate, yeah, ing. I'm just going to put a little extra at the point x, f of x. Okay, so estimate the value of f prime of x at any value of x by drawing the tangent line. We'll practice in a minute. You just draw a little line, decide or estimate what the slope would be right there at that value of x, or right there at that point. Okay. The slope of the graph of f becomes the y value on the graph of f prime. Okay, so we'll find slopes for f, use that as our y values when we draw f prime. And I've got 3 more things to go over. First one is when f prime is positive. F prime of x is positive or above the x-axis. When the slope of the tangent lines are negative. Let's see. Is it positive? When the tangent lines have positive slope. Okay, so f prime is negative or below the x-axis when the tangent lines have negative slope. When these tangent lines have negative slope. Okay, last thing, and then we'll practice, is when f prime of x equals 0. function f prime crosses the x-axis. And that's when the tangent lines are horizontal. Just a reminder, horizontal lines have no slope, or the slope m is equal to 0. Okay, now we get to draw a picture. So the first function I'm going to draw is the function f, and it's going to be black, and I'll pick some other color to draw f prime. So you get your x-axis and your y-axis. We're going to draw them both on the same graph. In the book, they have one picture and then below the other picture, just kind of like matching. But we'll just kind of sketch them and use different colors. Okay, so I want to label 1, 2, 3. -1, -2. 1, 2, 3, 4, 5, 6. -1, -2, -3. Okay, the function f, it starts, it starts with a line that goes through 0, 2 and -2, 0. So right here, -2, 0, 0 up to, we go 3. Okay. It goes straight across from x equals 0 to x equals 2. And then it's, actually we are going to fill this in and come straight down to 3. So it's like kind of a triangle right here. But that's actually just a mark. Okay, above 3 and just across here, we'll have an open hole. Above 5, it'll kind of peak at the point 5, 3. And then we'll go back up when it hits 6. So we're going to come little min right here and then up again. That's the function f. Okay, let's talk about this one. F prime of x equals 0 when your tangent lines are horizontal. So that's going to happen right here. This tangent line, what's this do? Green's good enough. Okay, so flat line right here, horizontal line, which means the slope is 0. Same with one right here. So I know that f prime is going to cross the x-axis right at 5 and 6. I'm going to mark those right now, but we'll come back to them in a minute. Okay. I'm going to start from this side and work my way over. So let's look at this piece here. This part is a straight line, and if we drew the tangent line, which is going to sit right on it, it has a slope of, let's see, up 1 over 1, up 1 over 1. This is a slope of 1, positive slope of 1. So let's say something like when x equals -1, f prime at -1 is the slope at -1. The slope of the tangent line at x equals -1, which we just talked about, is 1. And there's a slope of 1 all the way from -infinity to x equals 0. So f prime is going to go flat at 1 up till here. Okay. F prime is going to be drawn in red. So it starts off going from a height of 1, open right here. Now let's talk about this piece. F is flat, and that's some slope of 0. So f prime is going to be 0 from here to here. Oh, actually, we could fill this in. Okay, so somewhere in there, like at x equals 1, f prime of 1 is 0. The slope of the tangent line when x equals 1 is flat, which means that it has 0 slope. Okay, between 2 and 3, let's pick something like 2.5. That tangent line would really just sit right there on the function. And it has a slope of down 2 over 1. So slope of 2. Sloppy. Oh, it's negative. Sorry, down 2 over 1 would be -2 for the slope. Okay, so between 2 and 3, f prime is going to be flat at -2. Okay, this is where it gets a little tricky, and I'm going to do some guessing. But what I did first is start at this part of the curve, and I kind of just held a ruler up to it, or I'm just going to use a flat edge, and just kind of got it where it was about tangent, and just used my sketch to get a slope, and I got a slope of about 3. So it was just an estimate, but I said we're going to go up about 3. These tangent lines have positive slope, so we're above the x-axis, and the slopes are getting, let's see, we're going to go not as steep, so the slopes are decreasing. So we're going to come down, hit the axis, and it's going to be right at x equals 5. So I'm going to go up to about 3 here. Come over here. Just going to swoop. Okay, between 5 and 6, these tangent lines have negative slope. So we're going to go below the x-axis. We're going to start to go below and then start to come back up as the tangent lines change. I went kind of close to -2, but just down and up. get a good sketch, a pretty good sketch. All right, now I've hit where the slope is 0, or where f prime crosses the x-axis. These are positive slopes, so we're going to go past the x-axis. The slopes get steeper and steeper, so we're going to increase up and over, like trying as close to that function. Oops. So I know that when I was introduced to this kind of problem, it was a little confusing, and I did see it when I took a physics class, drawing f prime of x. So let me know if you have questions. It will be on your homework. Let's make one more note. F prime of 5 is 0. And that's all I have. Okay, so again, this sketch of f prime can be tricky, but just let me know if you have questions on your homework. We can talk through it together. So this is going to be a definition. And there's 2 parts. Okay, so the definition of a function being differentiable. So a function f is differentiable Okay, first part. At a point x equals a, if f prime of x, if f prime of specifically a, which is the limit as h goes to 0 of f of a plus h minus f of a over h exists. Or on an interval. So f can be differentiable at a point, x equals a, or f is differentiable on an interval I. If, I'll read it first and write it down. If f prime of x, which is the limit, we'll write it down. If that exists for all x in the interval I. So on an interval, if f prime of x the limit as h goes to 0 of f of x plus h minus f of x over h exists for all x in I. All right. Then there's this theorem that's cool. It's a theorem which says that if a function is differentiable, then it is continuous. If f is differentiable, then it is continuous at x equals a. Okay, so differentiable implies continuous, but not the other way around. So I'm going to note down that if a function is continuous, it doesn't always mean that it's differentiable. Okay, so and this will be the last note for the day. Okay, so note f being continuous at x equals a. Does not always mean f is differentiable at x equals a. Okay, so one more time. Differentiable implies continuous, but I'll show you an example where continuous doesn't mean differentiable. So this ends there. Please work on your current assignments. I won't make any new assignments till after Wednesday. Okay, bye everybody. Have a good day.